Load a project. In your WCS Projects folder, go to Tutorials, GIS, GIS Basics Project. Save it as GIS Basics 8 to prevent overwriting the original project. Activate the main view. Render a preview. The environment is composed of two ecosystems we've worked with in previous tutorials, grassland and pine burn. The rules of nature work well for rendering convincing landscapes, but reproducing actual land cover requires real-world data. We're going to use vector data in the form of a shapefile to drive pine burn ecosystem placement. Shapefiles have the advantage of storing database information associated with the vectors. Search queries and thematic maps can save production time and can dynamically update when vectors change. Launch the Import Wizard. Make your way to the database folder on your VNS3 DVD and load the Pine Burn shapefile. The Import Wizard will correctly identify this as a shapefile. Next window, Load As, will load the window as a vector with render enabled. The Output File Type and Name window gives us the option to re-import when the project loads. This is for when you expect the input data to change and want it automatically updated when the project is opened. We don't, so continue to the next window. The Coordinate System Summary will show a custom coordinate system using the Geographic NAD 27 projection and system. Go to the next window. The Attributes section of the Shape Options page lists all the attributes VNS found in the shapefile. We're going to assign database names for an attribute field, load attributes, and add file layers, so make sure those are all checked, and import. We're going to stick with the coordinate system we have, so decline the offer to change it. The first Database Fields window is looking for attributes to load. Always double check what VNS is asking for here because the request windows depend on the choices made in the last window. We want all these attributes, so select all and OK. The next window here wants a field to assign a name, that is a name for the object in the database editor. Vect name should be a good choice, so OK. As soon as the data was imported, the plan view updated with vectors. The database editor also now has 9 new PB vectors listed in the Properties window here. Save the project. On the Attribute page, we see the vector name, sub-density, and DOM density, as well as ecos. Again, we have the vector name, the subdominant species percentage density, the dominant species percentage density, and the ecosystem type. On the layer page, the pine burn vectors are listed as part of 2 layers, polyline and pine burn. You probably can't read all of pine burn. If you can't, click on the column header and there you'll see pine burn. This also gives you access to other layer operations. Back in the main view, let's go ahead and switch back to OpenGL. You'll notice we don't see any vectors here. We see them in the plan view, not in the perspective view. Let's find out why. In the database editor, PB01, if we select that, you'll notice it becomes yellow in the plan view. That is active, so let's go ahead and edit that. This will open the Vector Editor window. Go to the Selected Points page, and you'll see in the lower right-hand corner here, we have the latitude, longitude, and elevation, which is 0. That means the vector is underground in the main view here. As it turns out, all of these vectors are underground, so we need to bring them up to terrain level to see them in the main view. By design, planimetric views show vectors regardless of their elevation, which is why we see them here despite their 0 elevation. Close the vector editor. Let's select the pine burn layer. The title bar here will update, reminding us we have 9 of 21 objects selected. use the Conform button and conform to terrain. Confirm, agree, and you'll notice now the main view shows vectors in view. Save the project.